Factoring day 2. Today we are going to factor polynomials with a leading coefficient of 1. To warm up, we are going to multiply, or as they like to call it, FOIL the following. So we did this a little bit yesterday. We had to multiply two binomials together. If you are not familiar with or you do not like the acronym FOIL, we can think about it as double distributing. So that means I would take x times x and I would get x squared. I would take x times 5. I would get 5x. I would take 3 times x. And I would take 3 times 5. What can be combined?
5x and 3x.
What does 5x and 3x combine to give me?
8.
An 8x, positive 8x. So that is our answer. If we multiply x plus 3 times x plus 5, we get x squared plus 8x plus 15. On number 2, again, we double distribute. We have to think about this as a negative 6 and a negative 4. X times x gives me x squared still. X times negative 4
Negative 4x.
is negative 4x. Negative 6 times x.
Negative 6x.
Say negative 6x. And negative 6 times negative 4 is a positive 24. What combines on this one? Good. The x's combine again, but they are both negative. So what do we get when we combine them? A negative 10x. So x squared minus 10x plus 24. Kaylin, we're going to have to put that away. Close it up, please. Thank you. All right, on number 3, we've got a positive 5 in the front, but we have to treat that like a negative 4 in the back. So still, we double distribute. We take x times x. What do we get? X squared still. Oh, I didn't box my last answer. Okay, x squared. And then we have x times negative 4. Negative 4x. 5 times x. Say positive 5x. And 5 times negative 4 is negative 20. When we combine our x's, what do we get? Positive x or negative x? A positive x. Thank you. All right. So that means we have, I'll write it at the bottom, maybe we'll be able to see it, x squared plus 1x minus 20. Questions on these? Before I erase them and show you something, well, something you might have already seen before. When I have taught multiplying and factoring before, just want to show you this real fast. Some of my students like to do it with the boxes. Have you seen this before? Where you put one of the binomials across the top and you put the other one down the side. And then like this box would be x times x. This box would be 3 times x. That's what would meet up in there. Down here we'd have x times 5. Oh, I forgot my x. And then down here we would have 5 times 3. Have you seen something like that before?
Yep.
Okay. So if that helps you kind of keep it straight, you can write those off to the side. It is more time consuming, but I keep hearing the same people answering when we double distribute, so I'm wondering if the double distributing is not something we remember very well. Okay, so if it helps to set it up in the boxes to see what's getting multiplied together, you can do that as well.
That call night is what you do.
Yeah, you can use it with multiplication and division also. And then again, we'd still have to like combine these terms before we write our final answer. Okay, let's continue on then. Oh. So today we are going to unfoil. It's also more often referred to as factoring. So we are going to work in the other direction. So we're going to start off with the x squared plus whatever x plus or minus whatever number and get to being in these binomials. All right. Let's get all our notes on there. To factor a polynomial of the form x squared plus bx plus c. First, check for a GCF. If it has one, factor it out first. List the factors of c, so the constant in the back. Factors meaning numbers you multiply together to get the c value. Choose the pair of factors that you just listed out that have a sum equal to the b value. And then we can always check ourselves by foiling or by multiplying it back out. So we can call this multiplying them back together. Whoop. All right, so we've got some helpful hints for determining the signs. All right. Our hints say if c, that constant in the back, is positive, then the signs must be the same. So if c is positive, the two signs have to be the same. To determine which sign, look at the sign on b and use that. So at the very bottom, they give us a couple examples. If we have x squared plus bx plus c, we're going to use two positives. If we have x squared minus bx plus c, we're going to use two negatives. So when c is positive, the signs have to be the same. If c is negative, the signs must be different. This is when it gets a little trickier. If b is positive, then the bigger number is positive. If b is negative, then the smaller number is positive. And they give us more helpful hints down here at the very bottom. So if x squared plus bx minus c is our issue or a problem that we're dealing with, then we're going to have x plus big times x minus small. If instead both signs are negative, we're going to have x plus small times x minus big. This will make more sense when we're actually dealing with real numbers. I always feel like I say that in our notes, but it's true. It makes more sense when we can actually see it happening with an actual problem in numbers, not just big, small, or variables. All right, let's do some examples. My recommendation for these is that the first thing we should do is check for a GCF. But we should be able to rule that out right away on the first one. Do we have a GCF? No GCF here. Okay, so right after you check for a GCF, if you know there isn't one, go ahead and set up your two sets of parentheses.
Look at the numbers and see if there's a number that can factor into all three or both.
Yes, if there's a GCF, something, either a number or a variable, would be able to divide evenly into all three terms. Okay? One does not work. Yes, I agree. It would be unnecessary to do one. All right. Once we have our parentheses, the next thing I would recommend is filling in your signs and your starting term if you know what those are going to be. What are we going to have to multiply together in the front to get y squared? Y and y. Okay, we know we're going to have to multiply a y and a y to end up with a y squared, so we can go ahead and fill that in. What are our signs going to be? Positive and positive. If we look at the hints that we just wrote down, it said that if C in the back is positive, then the signs have to be the same, and we use the sign that was on B. So they have to be the same. We're going to make them both positive. Now comes the fun part. We need to list out factors of C. What is C on this problem?
40.
40. So I need numbers that are going to multiply together to give me 40.
10 4.
10, 4.
Okay. What I recommend is going in some sort of order. So I like to start with 1 and work my way up. 1 times what?
40.
2 times?
20.
Can I multiply 3 by
No, you
something?
cannot.
No, so I'm going to skip 3. I go to 4. 4 times?
10.
What about 5? 5 times 8. What about 6? 7? 8?
Yes.
Yes, 8 times.
3.
5. This boy.
What am I trying to multiply to?
40.
40. So 8 times
5.
5. That's already on my list. Once you hit a duplicate, you stop. That means you got them all. So we're not going to write down 8 times 5 because we already have 5 times 8. It's the same thing. We want the pair of these that adds up to what?
40.
Nope.
Oh, 14.
14. They all multiply to 40, but which pair adds to 14?
10 and 4.
10 and 4.
10 and 4.
I think I remember some of this.
So we fill in a 10, we fill in a 4.
What if there's 4 and 10?
If you would rather put 4 and then 10, that is the same thing. It's fine because they both have the same sign anyway. Okay. Questions about how we did number 1? All right, on number 2. Let's start setting up my binomials. What's going to go in the front?
Y.
A y, because that's how we get a y squared. What are our signs going to be?
Positive.
Both positive. Okay, we've got a positive C and a positive B, so they will both be positive. We need 2 numbers that multiply to what?
7.
7.
And add up to
8.
8. Those 2 numbers are going to be
7 and 1.
7 and 1. So sometimes in the past I've done like where we do a multiply column. So it would be like 1 times 7. And then we do an add column where we change it to 1 plus 7 to check to see that that equals what we want it to. Okay, some people call it the MA method. Multiply and add. Obviously there's nothing else on my multiply list to check. So good thing it worked out. And that is our answer. So our answers on these are going to be 2 sets of binomials. Unless we have a GCF, in which case there will be more to our answer. All right, number 3. What's going to go in front of my binomials?
Y.
Y's. What are my signs going to be?
Negative and negative.
Negative and negative. Here, the plus sign in the back says our signs need to be the same. The minus sign in the middle says they both should be negative. I'm looking for 2 numbers that do what?
Add up to 11 and multiply to make 18.
Add to 11, multiply to 18. So it's easiest to start with numbers that multiply to 18. What numbers will multiply to 18?
1 and 18, 9 and 2, 6 and 3.
Okay. When you're making your list, if you come across the pair that you need, you don't have to keep on going with your list. So where could we have stopped this list?
9 and 2.
9 and 2, because 9 and 2 add up to 11.
Why do we have to do that?
To review. All right, on number 4. What's going in the front of my binomials? Z. What are my signs going to be?
Negative, negative.
Negative and negative. What are my numbers going to be?
5 and 1.
5 and 1. Be careful on this one. I have a lot of students on this problem telling me 2 and 3. For whatever 6s and 5s get us all mixed up. We need them to multiply to 5 and add to 6 this time. If we were to switch where the 5 and the 6 were, then we would want a 2 and a 3.
So sometimes we don't need to show our work.
Yeah, sometimes on these I'm not going to require that you make me a list. I was just showing the lists for people who need to see how we're coming up with these. So if you need to see a list on this one, we've got 1 times 5 and 2 times 3. If we take 1 plus 5, we got 6. If we take 2 plus 3, we get 5. But this problem says we want the one that adds up to a 6. So that's why we went with the 1 and 5 and not with the 2 and 3. Oh, we wouldn't use 2 and 3 anyway. Sorry. That doesn't even make sense. But I was switching them around in my head. We really only had one option on that one also. All right, if you're still working on these, that's okay. I'm going to start putting the answers up so you can check yourself against the answers. And we might have a minute to talk about a couple of them if we need to. All right, on the first few of these. So on number 5, we should have ended up with 2 times u plus 2 times u plus 9.
So on these ones, the numbers don't have to add up to the middle number?
So it won't look like the numbers add up to the middle number. That's a good question. So it doesn't look like 2 plus 9 is going to add to 22, right?
Mm-hmm.
But it doesn't because what did we do before we came up with the 2 and the 9?
We took out a 2.
We took out a 2. So if we take 2 plus 9 times 2, will that give us 22?
Yes.
Yes, 2 plus 9 times 2. Same thing back here. If we take 2 times 9, what do we get?
18.
18 times 2 gives us the 36. Okay, so the step that I would hope that you wrote in the middle would have looked like this. Okay, this top part here, 2 times u squared plus 11u plus 18, that should have been like your middle step. And I would want to see that. I'm just going straight to the answers for the sake of time. What was our GCF on number 6?
X.
X. So once we factor out an x, we've got x minus 7 times x minus 4. Questions there?
No.
All right, on number 7, the first thing I factored out was a 3. That leaves me with s minus 10 times s minus 2. Questions or concerns there? On number 8, what was our GCF?
X.
This one was an x again, and then we've got y plus 24 times y plus 1. Did anybody get to number 9? Okay, thank you. Anybody get to number 9? Anybody try number 9? Let's do number 9 together. So let's make a little list here. We are looking to multiply up to what number?
14.
What numbers multiply to 14?
1 and 14, 2 and 7.
1 and 14, 2 and 7. If I take 1 plus 14, what do I get?
14. Wait, 15.
15. So if I add them, I get 15. If I add 2 and 7, I get 9. Are either of these going to work?
No.
No. If you come across a polynomial that will not factor, we call it prime. If it will not factor, we call it prime. Questions before we continue? We are just going to keep on powering through here. Okay. Powering through. These ones are a little bit different in that we've got a minus c. So we're subtracting c in the back. So these ones we have to be more careful with our signs.
It's a negative then a plus.
We do know from our hints that one of them will be adding and one of them will be subtracting. We do still want to multiply to a 35 and add up to a 2, but it's got to add up to a -2. So let's first work on what numbers are going to multiply to 35.
1 and 35.
1 and 35. What else?
2 and 17.
2 and 7. Oop, not 2 and 7. Sorry.
17.
5 and 7. Anything else? No, right? 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 works. 6 does not work. 7 gets us back to the same pair. So, which one of these pairs, if I make one number positive and one number negative, is going to give me a 2?
7's gonna be negative and 5's gonna be positive.
We need to use the 7 and the 5. And I heard that the 7 is going to be the negative and the 5 will be the positive. You can go back to your hints, or you can think about the fact that we need -7 plus 5 to end up with a -2. Or the hint says that the bigger number gets the sign that's in the middle, basically. So the 7's bigger, it gets the minus sign. All right, on 11.
Negative, positive.
We again need one positive, one negative. What number are we trying to multiply to?
Negative 4.
Trying to multiply up to a 4 and add up to
3.
a 3. What numbers will multiply to 4?
1 and 4.
1 and 4
2
and 2 and 2. Which one of those is 3 apart?
2, I mean 1 and 4.
The 1 and 4 would give us a difference of 3. Which one needs to be positive?
4.
Oh. So the bigger number gets the sign in the middle. So which of these is bigger?
4.
The 4. So the 4 is going to get the bigger sign. The 1 goes with the minus sign. The 4 gets the positive, the 1 gets the negative. And if we think about it, 4 minus 1 gives us a positive 3. All right, on number 12. Again, if we have a minus C in the back, our signs are going to be plus and minus.
5 and 3.
Good. My factors of 15 that are 2 apart would be 5 and 3. Which
5.
sign should get which number should get the plus sign?
The 5.
The 5. The plus sign is in the middle, so the bigger number is the 5. The smaller is the 3. Again, it doesn't hurt to double check. Positive 5 minus 3 is a positive 2. Yes. No. Okay. Number 13. We've got, what is the number in the middle here?
1.
One.
Negative 1.
Negative 1. Okay, so we have to treat this like a negative 1. So that's what we're trying to add up to. Again, we have a negative C, so 1's plus, 1's minus. What factors of 20 are 1 apart?
5 and 4.
5 and 4. Which one gets the plus sign?
4.
The 4. The 5 gets the minus sign because the sign in the middle is negative and the 5 is bigger. So the bigger number gets the middle sign.
We ran through these.
We did go through those very quickly. Do we have questions about those so far? We just got a couple left. I knew we could do it. Go team. Okay. 14 and 15. Again, what do you think we're going to check for on these?
GCF.
A GCF. We should always be checking for a GCF, even though I didn't really
4.
emphasize it on the last set. City has said our GCF on 14 is a 4. What do we have left when we factor out a 4?
4. No, 1, 1, and 2.
We have an S
Well, okay.
squared
S squared.
minus 4S plus minus 8.
Careful, because we're factoring the 4 out of every single term.
Oh, you're minus. Oh, S
Minus S minus
2.
2. Very good. We got to factor it out from every single piece. Then we can set up our two binomials. We know we have an S in the front. What do we know about our signs?
Negative and a positive.
They've got to be opposite signs or different signs because we are subtracting the C back there. All right, we need to multiply up to what number?
8.
Nope.
Oh, 2.
2, right? We changed it. We're multiplying to 2 and we're adding to a -1. What are the only numbers that multiply to 2?
2 and 1.
2 and 1. Which one gets the plus sign?
1.
1. Very good. So the bigger number gets the sign in the middle. The bigger number's 2. It goes with the minus. That leaves 1 to go with the plus. All right, this last one is a little confusing, I would agree. What's our GCF?
Y.
Not just Y.
XY.
XY. We can take out an X and a Y from each term. If I factor out an XY, what am I left with?
Y squared.
Y squared plus 8 Y
minus 9.
minus 9. Very good. So we took one X and one Y away from each pair. Then we can keep factoring. The XY stays out in front when we make our parentheses for our binomials. What goes in the front of the binomials?
Y.
Y. What are our signs going to be?
Negative. Wait, negative, positive, sorry.
Negative and positive, or positive and negative. The C is negative. That means the signs are different. We need two numbers that multiply to give us
9.
a 9. 9 and what?
1.
9 and 1. Our other option being 3 and 3. But we choose the 9 and 1 because we need it to add up to 8. Which one is going to go with the plus sign?
9.
The 9. The plus sign's in the middle, so the bigger number goes with the plus sign. The 1 has to then go with the minus sign.